Any sufficiently advanced technology is indistinguishable from magic.
So it is a great pleasure to be joined by a Brian who did not lose the Nobel Prize, but instead won the Nobel Prize. Brian Schmidt, co-recipient of the 2011 Nobel Prize, the Vice Chancellor of the Australian National University. You may know them as the Owls, the Fighting Owls. I believe that is their wonderful mascot, a wise mascot indeed. And today Brian is joining us from all the way down under in Canberra. Is that correct, sir?
That is correct, although I don't think the Owls are a mascot, although I like the sound of it.
Well, that's what the so-called internet would tell us. So maybe it was retracted. The owl was put out to pasture. But it is lovely to be chatting with you today. You are my 11th Nobel laureate to be joining us, and this is the 10th anniversary of your receipt, along with past guests Adam Rees and Saul Perlmutter, of the 2011 Nobel Prize. So I thought it was about time for me to extend a proper invitation. And one of the things that's always intrigued me about you is your fascination with wine extends all the way to the most important of all monikers, your Twitter handle. And I thought we'd start with a quote from the very first observational astronomer to ever use a telescope in reality to explore the heavens. And that is, of course, my hero Galileo, who said, "Wine is sunlight held together by water." And I had the honor to host a conference in 2015 on the relativity anniversary centenary at Galileo's final villa in Florence. And he had a vineyard there where he also said the sun, with all those planets revolving around it and dependent upon it, can still ripen a bunch of grapes as if it had nothing else in the universe to do. Now, you have a lot of things in the universe to do, but tell me, where do you find the time to be a vintner and to explore the properties of this fine elixir of Dionysus?
Well, you just have to make time. One of the things about this job, and when I applied, so the vice chancellor for Americans is the president of the university. Not a job I would necessarily recommend most people take, especially in the era of COVID. It's been quite a ride for the last couple of years, but you just you have to make time. And when I was interviewed for the job, I kind of went through and said, well, okay, there's, this many hours in a week. I'm going to sleep for about 50 of them. How many hours a week do you want me to work? And how many hours do I get to do things like make wine? And anyway, I convinced them that I could still work an absurd number of hours and make wine. And you make time. It's good because you need to decouple from anything and everything you do. And obviously, of course, up at Archetri at Galileo's Villa, which was his prison, a pretty nice prison though,
Yes, yes.
from my standard. He drowned his sorrows in wine, which is something you probably don't want to do. But for me, it's just a way of getting out and thinking. And I often think about astronomy or the problems of the world while I'm out working in the vines. But it is a way, as I said, to de-stress and get some exercise and just do something that's a little different.
Now your handle is Cosmic Pinot on Twitter, and harkens back always to the famous movie from the early 2000s, Sideways, where they are really besotted with either support people that are obsessed with Pinot and people that hate Pinot. But I looked up, where does Pinot grow, and it grows pretty much. And you'll of course disabuse me if I'm wrong, but it grows predominantly in latitudes between positive and negative, 30-ish latitude, negative south to negative 37 or something like that. And I know Canberra is in the middle of that latitude band at exactly minus 35, I believe. Was that another part of your choice way back in the late 90s, I believe, when you took up residence in Australia?
Yeah, so Pinot Noir, you can grow Pinot Noir in warm climates, but it produces a very innocuous wine. It just kind of produces red. And it's a kind of a painful grape to grow because it's not well behaved. It puts shoots everywhere. It has small bunches. It easily gets disease. So if you're going to grow red, it's not the grape of choice. You're going to use something else. Shiraz is much easier to grow. But Shiraz needs a little bit warmer to ripen properly. So here in Canberra, Canberra is up at elevation. So we're at my vineyards at 750 meters, give or take a little bit. So 2,200 feet. So about Tucson, Arizona, if you're in the United States, of course, where I went to university.
Yeah, on the water.
But it's so we have the same latitude almost, a little further north of Tucson, but it's a very different climate. It's much more cool here, and you need to choose the grape that's appropriate for the temperature that you're at. And so Canberra is such that Pinot is the only one of the major grapes of red, especially 20 years ago when I planted, that you could sensibly ripen every year. I have a little bit of Shiraz planted now. It's hard to ripen, but I can get it ripe in at least the warm years, and it's my climate change hedge. But yeah, it's you choose based on the climate if you're smart, and if you're dumb, you plant grapes that don't get ripe, and that's not a lot of fun.
Now, wine is used in my religion of Judaism for many purposes, but one of which is to celebrate the fact that wisdom improves and people's wisdom improves with age, and also bread is used to signify that people that certain attributes decay over time. I wonder, is the kind of the appreciation with time, is that sort of storage, as Galileo said, sunlight in a bottle? Is there sort of a stoic property of this wine that appeals to you, that you can grow it now, delay gratification? Admittedly, this is a little bit loaded question, but storing up and delaying gratification, which sometimes we have to do as scientists, is that an appeal, or is it just merely the pleasure and the earthly nature of of your concoctions?
I really do like the time, and wine is time and place, right? If you think about it,
Mm-hmm.
I get to take wine from Italy and bring it to my house. I get to take my product, but then there's this delay. It changes over time. It takes years to actually create from grape to bottle, and then years more to really evolve. And you can literally go in. I go through and I do think back. Oh, here's a bottle of wine that I bought in grad school. And that wine was made in France in 1982. And so I'm getting a chance to, you know, I guess, connect back to, a different time and place. And so I do find that as a nice part about fine wine. Of course, you don't have that type of wine every day of the week, or if you do, I
Right.
think you get bored of it. I know people who do, but I think you use it to celebrate occasions sometimes. And it's to say that that long haul that wine represents, I think, is to me actually a really attractive character.
Yeah, absolutely. And last wine related question before we either turn off our colleagues that are in 12-step programs or bore other people. What about pairings with food? How do you find, is that part of the pleasure as well? Or is it something to be savored separately, as we have in California? You can't have a restaurant as part of a winery tasting room because they kind of want to separate those two functions for some reason. But what about pairing with food and so forth? Is that part of the challenge, the fun, the collectability nature of what you do?
So, yes and no. I mean, some wines really go well with food, and others, pairings don't quite work well. But I'm not obsessed with it. To my mind, I want to get something that's sensible. So I choose wine that's appropriate when I'm eating. If I'm going to have a fish, a really light fish, I'm not going to go and get a monster Shiraz because they just don't work very well together. Lobster and Shiraz don't work well. Lobster and Chardonnay, on the other hand, that's a pretty good combination. So, but I'm not super fussy about it. It's I make Pinot Noir, so Pinot Noir kind of covers a broader range of food. You can have everything from steak to tuna and stuff. So that's why I kind of like it. It's a flexible wine, but
Yeah.
I try to pair to a reasonable amount, but I'm not obsessed with it.
Ah, it's kind of the utility infielder, as we would say here. I don't know if
Yes.
cricket has an equivalent down under. I want to now go back to your past, explore your low redshift activity, at slightly higher redshift than we are now. So you grew up in Montana. Although I should point out, Brian, when you go to the NobelPrize.org site and you look up the facts about Brian P. Schmidt, it says Brian P. Schmidt has not submitted an autobiography. Is there like some time limit on that they're going to eventually come back and rescind the prize or something if you don't submit your autobiography?
Well, it's quite interesting because the actual piece I gave is quite autobiographical,
Yeah.
and so um, it's easier instead to sit down and write your autobiography. But I'm still living my life, so I figure I've got another 20 years in me.
Well, as long as you get to it, that's all that matters. I want to talk a little bit about, yeah, going back further. You were early years in Montana and Alaska, undergrad at University of Arizona, and then at Harvard, and then basically from there to Australia. Talk about your dad. I recall from reading a little bit of background about you that he was a scientist. He was a biologist involved with fish and game, etc. A lot of the laureates, including Adam Rees, your co-recipient, one of your two, he credited a lot of the kind of curiosity and scientific inquisitiveness that's so important in his kind of past world line. He credited a lot to his dad, and I wonder if that had any bearing on your career choices.
Yeah, I'm very much a product of my mom and my dad. So my mom passed away in 2009. My dad's still a fisheries biologist, still doing some work up in Canada. Although he's 75 now, so he's trying to do a little less.
Hmm.
So yeah, so my parents had me when they were really young. My dad had just turned 20. My mom was 19. I was what they called a sophomore surprise back in 1967. And as my father started going and doing a master's degree and then a PhD, I of course was, on his side a lot because there wasn't a lot of childcare back then. My mother was working to help pay the bills because PhD stipends, as bad as we think they are now, they were worse in the past. I think it was pretty tough,
Yeah.
and having a small kid, so he did a lot of babysitting, and I remember going in the lab, and my father loved science. He was just passionate about it, and so I got to see that. And my mother, not a scientist, but someone who was a very dynamic person and very good with people, and doing just getting things done. It was an interesting combination between the two of them. So I'm a bit of both of them actually. But that time with my father was, I think, really instilled in me from a very young age that I wanted to be a scientist. I wanted to be a scientist as early as I can remember, since I was 3.
And the type of science you ended up practicing couldn't be more different, I suppose, from for biology. I always joke I was such a bad biology student that when I would dissect a frog, the frog would live. I was just not cut out for biology. And then you were at Arizona and you got involved with an experiment, a CCD camera that was used in a transit survey that would later, I believe, pay dividends for things like Sloan and other things. That seems like a pretty big leap from kind of fascination with fish and game, growing up in Montana and Alaska, to astronomy. Was that a product of remaining in the West in the United States, or was it something that had been kindled earlier? Because as I say, it does seem a little bit at odds with biology, just to be
Well,
blunt.
I love science, and I still love science. I could have become a biologist. I was really fascinated with becoming a meteorologist.
Mm.
And so the fact that it was science or whatever, the whole scientific process of trying to understand, experiment, learn, design experiments, be wrong, modify, that type of thing, that was always what interested me in science. So I actually like science of almost any flavor. The only science that I'll be honest, that I never really liked much as a kid, which is quite of interesting, is I always struggled in chemistry. Uh, Not so much because it was just very formulaic, and
Mhm.
you didn't get to mix things together and see what happened, because if you did, you might do something bad, right? So you always had to kind of follow recipes and things. So chemistry never quite worked the same for me. But
Mm.
I can remember an eclipse when I was 3 in Oregon. I can remember Comet Kahutek, the
Mm.
failed comet, when I was 6, 73. Comet West which was not a fail in 76. Got a crappy but useful telescope, that my parents could afford when I was probably 8 or 9. I remember seeing Jupiter for the first time. Telescope when I was 13. I started then calculating eclipses and things because I was an early computer nerd, and so one of the cool things I figured I'd do is how to calculate when solar or lunar eclipses didn't wasn't good enough to do solar. I could tell when they were going to curve. I didn't know where they landed on the Earth, but the lunar eclipses I could do. And so those are the things that I did. And so I was always interested in astronomy. I just never thought it would be a job because only the smartest people in the world become astronomers. And I clearly wasn't the smartest people, one of the smartest people in the world. And I was a good student, but I wasn't, one of the top 5,000 people in the world.
Mhm.
So I had this view that I should probably astronomy wasn't going to be on the cards. But then I decided after working at the National Weather Service that the forecast office and things that I was expecting was not as scientific as I had hoped. And I said, oh, crap, I don't know what I'm going to do. Okay, I'll do astronomy until I figure out what I'm really going to do. That's how I ended up doing astronomy.
Ah, okay. And then, of course, you had the good fortune to end up at Harvard with Bob Kirshner and also sharing an office with past guest Sean Carroll. And then we'll get into some of your commingling between his theoretical approach to dark energy and your obvious experimental approach. But one of the things that most tickles me about your advisor, Bob, which maybe you can comment on. After the announcement in 2011 that you and Adam had won the Nobel Prize, I should say Adam was also his student as well. He made a comment and he said, "Hey, what's the strongest force in the universe? It's not gravity; it's jealousy." What do you think he meant by that? I've never asked him actually what he meant by that. What do you think that was meant to imply?
Yeah, I mean, I've heard him say that before the Nobel Prize. I mean, it's when it's anything, a discovery. So I'm going to take it away from the Nobel Prize. I'm talking about the discovery back
Mm.
in 1998, So uh, Saul Perlmutter's team, Supernova Cosmology Project, the High Z team, were in a pretty brutal battle, which, probably unnecessarily so. I mean, science should be competitive, but it should be constructive, right? And our battles were largely constructive, but not entirely so. And so there was a genuine worry by both teams that they were going to get scooped by the other team and not get the credit. And that force of jealousy is really, really intense about people. And I'm a pretty mild mannered person, and even I felt it. And that goes through whether or not who gets prizes and all these things. The world's not always very fair, and it's not. It's something we need to remind ourselves is that there's a lot about luck being at the right place, the right time. Normally, it requires lots of people doing good work, but there's a huge amount of luck involved in being at the right place at the right time, and people really do feel jealous that they were just not quite at the right place at the right time or whatever, and I get it because it's not really fair.
Yeah, I wonder to what extent, things like prizes or accolades contribute to it. Because, speaking abstractly, does it matter that, as long as we have this knowledge of the universe, as if we're pure scientists, we shouldn't care who gets there first. Of course, for the benefit of the taxpayers who fund us, we want to do it in a timely fashion. But, ideally, I don't know if you would agree with that, but ideally, it shouldn't really matter who gets there first. Of course, you could say the same thing about getting on the moon, and obviously that was a big. But you would like to think of scientists as kind of above those sort of petty, human desires. But I think it's almost maybe a misconception that science is not competitive, right? That we don't have needs and desires for things that probably stem from just limited resources, right? What would you attribute this need to be to achieve priority? Is it similar to nation chest thumping, getting on the moon, or is there something different at work?
Well, it depends a lot from person to person. We have a hyper competitive field. There's a lot more people who want to uh, become researchers in astronomy than there are positions available. We have a way of deciding, who we think is, worthy of those positions. That is probably far from being, the optimal. And so people do whatever they can. They're really focused on that getting credit for who and what they are. And I think that physics and astronomy selects for pretty competitive people. They've had to be competitive to get into the university and the graduate programs and postdocs, and they remain. They don't suddenly just say, "Okay, I'm there. I'm going to chill out now," and be really easygoing. Um, so it's part of human nature. Competition is important because it does make things happen more quickly, but it can be destructive. And so
Mhm.
there's got to be a balance between a bit of competition, but to my mind, it should always be healthy and happy. And you don't want to. It needs to be done openness. What it really bothers me is when you get competitive and then you hide your results and you hide your software and things then don't become they become irreproducible. The goal is to get the science done as fast as we can.
Yeah.
Absolutely. And so a little competition good, a lot of competition bad.
Mhm. I've heard somewhat, to me, disturbing, predictions about the future of science, including things like, blockchain technology being used to produce effectively NFTs of, the first microscope image of, a certain whatever gene or virus or what have you. Or you could imagine the first, telescope images of of a Type 1A supernova at this redshift. Would you worry about that, or do you see, as I do, also a place for maybe eliminating some of the pressure to beat the person to publication and all the shortcuts that can entail by maybe putting out a result in a crypt in a blockchain format so that everyone could see it embedded in digital amber, so to speak. Do you worry about any of the new technologies coming online, or do you think that they could have a beneficial effect for science in terms of removing obfuscation and the deleterious aspects of competition?
Well, like anything, there's two sides. So let's say you use blockchain technology so that I can instantly release my results out there, and then people can build on that, and I get credit for it through the ledger system.
Yeah,
That would be a real positive.
yeah,
Imagine I change it and said, I have this with blockchain and I keep it in a form where you can tell and prove that I did it, but you don't get to use it. So my goal is to
yeah.
keep you so you know what I've done, but you don't actually get to do anything with it. I think that would be bad.
Hmm.
Right. And, proprietary periods are necessary to a point, but ultimately you want to minimize them because they hold things. There's a balance of openness versus giving people enough time so that they incentivize to do the best they can with it.
Hmm.
That's a balance we're just going to have to keep going on.
And sticking with the theme of mentorship, etc., in your Nobel lecture and your paper, what have you, you talked about how the teams kind of agreed, or your team agreed, to really promote the kind of contributions of young people, including postdocs as you were at the time, and graduate students as Adam was at the time, and explain the thinking behind that, because as you said, there is a limited number of postdocs. There's a limited number of graduate students. I call it the academic Hunger Games. It's like every stage you go up, it's harder and harder to get a job. Except actually for postdocs to be, it's actually not so challenging to get postdocs nowadays. It's sort of a seller's market where the postdocs are more in control. But in the buyer's market of faculty jobs, it's almost, we have 400 to 1 applications for a single physics faculty slot here. I assume it's also incredibly challenging there. Is it fair to young people to kind of have the surplus of the second tier to being, if you consider it that, just speaking loosely, I don't mean it denigrated in any way, but at the postdoc level have a surplus of slots only to find this brick wall that they can't go beyond? Is that fair to young people to kind of artificially inflate their hopes, or is that just a natural outcome of a very competitive field of academia?
Well, it's as long as we go through and people understand what's happening, and we do understand why it's happening. There's a lot of research done at the postdoc level. There are a limited number of permanent faculty spots. There's a lot of postdoc spots. The number of postdoc spots relative to PhD stuff is sort of found in equilibrium. But people need to understand that you know postdocs are a wonderful opportunity in some cases, and if that's where your career finishes up, and then you go off and get a job outside of research, that's fine. And we need to prepare and give people the opportunity to do and that transition well, right? So we need to be honest and open about it, and we need to make it so that it's a good thing, not a bad thing, right? And I'm here to tell you, I hate to tell everyone, but the pinnacle of my time as an astronomer, not winning the Nobel Prize, it was actually being a postdoc, right?
Mhm. Yeah.
Once you get beyond that, then you have to do a lot of things that are less fun in life, right? You have a lot of responsibility. So enjoy the postdoc, and if you don't become a professor, that's okay. You have done the fun bit, and now you can go on and get a different job that isn't that, and life will be good. So I think we need to be honest, open, and transparent, and quit catastrophizing it. It's okay not to
Right.
become a professor.
You're not a failure, right? If you don't become a professor.
Absolutely.
Right. Yeah. Some consider it the kind of a consolation prize of a kind, because it is very different than what you perceive it to be when you're an undergraduate or a graduate student. Speaking of postdocs, when you were a postdoc, your goal was to measure Q naught. I wonder if you could explain what was the mentality, what was the psychology going through your mind? You were using this tool and technology, and by the way, you had other opportunities to do other things, and you are reported to have said, you could think of no other place that you'd rather be than to be embedded in the expertise of Bob Kirshner's group. So I think that speaks very highly of Bob, but also of your just tenaciousness to focus on a single goal. What is Q naught? Why were you obsessed with measuring that? What did that imply if you were successful? How you might have, not led to down the path that you ultimately achieved? What was Q naught like in the '90s or the mid '90s when you were working on it?
Yeah, if you think about cosmology, I mean, and there's the Sandage quote is that
Right.
cosmology is a story of two numbers, H naught and Q naught.
Yeah.
So for my PhD, I was remembering H naught, and of course, being able to move to the other number, Q naught, as your postdoc, seemed relatively attractive, right? So it was the Holy Grail. Now, it was the Holy Grail because we thought the universe was simple, and we thought that curvature, density, and acceleration or deceleration were a one-to-one correspondence, right? Because there was
Hmm.
only one thing you had to worry about, which was omega matter. And that one-to-one correspondence meant if you know Q naught, the thing that you could easily measure, then the game you measured everything, right? So it was the Holy Grail. My God, the beginning and the end of the universe, the shape of space. Uh, you know, that's why it was so exciting. And fortunately, the world was, or maybe I mean for me, very fortunately, the world was complicated. But when we were doing it, it was literally being able to be part of measuring both numbers that describe the universe is large
Mm.
scale the large scale description of the universe.
So Mark Twain reputedly said, history doesn't repeat, but it rhymes. Do you see any rhyming iambic pentameter in this Hubble tension? People are expecting the two different measurements, the Hubble constant, to agree. The early time CMB, late time supernova, and Cepheids and stuff that Wendy Friedman and Adam Rees and others work on. They're discordant. That's claimed to be a crisis, as your fellow laureate, the late great Steven Weinberg, said. Physics thrives on crises, but today, unfortunately, there's not so many. That was back in 1989, by the way. But nowadays, what do you make of the Hubble tension? Could that be the search for two numbers, except they're the same number? Or, is there a much more prosaic thing that might be lurking as an explanation?
I don't know. I mean, right now it's not a crisis. It's I've got the piano out and I played a note and it's out of tune. It's like, ooh, it's all sounding great, but there's something wrong with that E down there. Because the discordance is there, but it's not huge. It's not 22 sigma. It's 5 or 4. Depending on who and how you deal with it.
Which is about the
And
level of lambda detection that you guys made the first
no,
time,
no,
right?
indeed it is, and that's
Yeah.
why the lambda we didn't say discovery, we said observational evidence for, right?
Right. Hmm.
And I always tell the story that in 2000, when Boomerang and Maxima came along, and I think we always forget about Maxima, but Boomerang and Maxima were literally a day apart. right? And
Definitely.
those two came out, measured the peak of the cosmic microwave background, which told us that the universe was flat.
Yeah.
And then the supernova measurements went from being kind of 4.5 to being about 8 sigma.
Right.
And I remember seeing that on AstroPH and going to my wife and I said, I'll be damned, we're right. Because at that point, I knew it had to be right. We're
Yeah.
not there yet in the discord of the Hubble stuff. Now, so I suspect there's a problem, but I'm not positive. And so I cannot yet tell you, is there something funny going on with, the cosmic microwave background and how it measures uh, the effectively the Hubble parameter and then extrapolates it back down to low redshift? Is there something funny going on there? I'm still mildly concerned about things not being exactly as you might expect between the different scales of the cosmic microwave background, but it's not a huge effect. Or is it just that measuring the value of the Hubble constant in the nearby universe is really hard, and despite everyone trying hard, there's just something that didn't quite get it right.
Did
So I
any?
could go either way. I really and I just don't know.
Mm-hmm. Your thesis measurement, if I'm correct, involved physical properties of a type 2 supernova, right?
Yes.
Um, is anyone proceeding in those directions anymore as a physical way that's not dependent on underlying cosmology? Because that would seem to break some degeneracies.
Yeah, I mean the challenge is that people are continuing to do that, but the physics is hard, and so we thought that the physics was probably good to a Hubble constant within about 10%.
Mm-hmm.
I reckon now we could probably do it to 5 or 6, but you need to be down at 1. And I think that inhomogeneities and the supernovae, the asphericity of them, those are all things that make it hard. And using type 2 supernovae is really intensive with respect to making measurements. So it's a harder thing than supernovae. It's direct, but I just worry that the physics knowledge, there's just not enough people, I think, running big codes to be sure that we've got the actual underlying physics down well enough.
Mm-hmm.
There's dust, there's circumstellar material, there's all this crap. They're not perfect objects, so
Right.
they're useful, but I think probably not good enough to do this question.
One of the things that I think made the discovery of your teammates and yourself um, uh, so pure and maybe emblematic of great discoveries, in my humble opinion, is that it was basically serendipitous. In other words, you were actually setting out to measure the opposite of what you did measure. So confirmation bias is sort of filtered out to some degree. And I wonder and I worry, with the Hubble tension being what it is, now everyone's looking for their theory to confirm these measurements rather than the other way around. And so by its nature, it probably can't be resolved in such a pure way as, say, the dark energy question. But that's just an aside. I mean, I view the serendipitous nature of that discovery as quite striking and reminiscent in a rhyming sense of the CMB's discovery, which was also serendipitous itself. In your lecture, in your Nobel lecture, you start off with a brief overview of 20th century cosmological models, and you talk about Einstein and what he called his wonderful thought that inertial and gravitational acceleration were equivalent. And I remember knowing a little bit about that as a younger person. And I believe the quote kind of was prompted by his realization that if you were in free fall, you would experience no gravitational forces, and even if you were near a gravitating body. And so he called that his wonderful thought. I want to talk about artificial intelligence because there's a lot being made about artificial intelligent physicists, and that there'll be an artificial AI Einstein, AI EAE, and there'll be all sorts of great things. But that quote that you quote and the preceding sentence about falling in a gravity, it doesn't strike me as something a computer could identify with. First of all, a happy thought, a wonderful thought. What does that even mean? It seems uniquely human. And also the notion of falling, I mean, an experiential, visceral sense, literally, that prompted Einstein. Do you think artificial intelligent physicists can make an Einstein-like contribution? Can they create the laws of general relativity from just observational data, or do you think it's being a little bit too much wishful thinking?
Well, certainly AI as we are right now is nowhere near. I mean, I think people have to remember that AI right now is really just interpolation, and it's a fancy interpolation. It does not extrapolate at all, right? So, one of the reasons why self-driving cars are a problem are edge cases where humans can extrapolate and say, I've never seen this before, but I'm pretty sure I know what's going to happen. And I'm afraid that your machine learning algorithm says, I've never seen this before, and here's your answer, but has nothing to do with anything. So current versions of machine learning, not hopeless, right? It's
Hmm.
it's about finding patterns in data that you have. So you might discover new and interesting things, but it's not gonna have that aesthetics that Einstein had of seeing some poor guy fall off a house and saying, "Hey, that guy is doesn't feel gravity. What a wonderful thought!" As opposed to, "I should probably call the ambulance and help that guy out because he's probably hurt." So that aesthetics is certainly a long ways away. Now, you know, computer artificial intelligence may become much more human-like in the future, but it's not there anywhere there right now. So I could imagine it finding little patterns in data, and what I think might happen is you'd go through and you'd say, I suddenly can predict something in physics that I'm surprised I can predict. Why can I predict that? We'd go through the different layers of the neural net and say, there's a pattern in there. Why is that pattern there? And then we would go through and use human creativity to try to understand it. That's how I think it might happen in the first instance. But I think we're a
Hmm.
long ways away from computers disintermediating physicists entirely.
Yeah, yeah, I agree. I often say I think computers can beat humans at chess, but I don't know if they can invent the game of chess. I want to turn back to competition. You said in an interview with a fellow astronomer Brian Greene, earlier this year, you said that the atmosphere between the TIZ and SCP teams was toxic at times, and you regretted that. And you said you were not proud of it. Now you were a postdoc. You weren't. There were many faculty members on each team. Why do you say that you personally weren't proud of it? And what were some of the benefits of that competition as ultimately proven out by the solidity of the discovery?
Yeah, well, and when I was a postdoc, but I was the leader of the team, and I guess I was friends with a lot of people on Saul's team, and so we kind of joked and all going through our do we have jobs? These are the questions we used to talk about. But the I guess the toxic thing is just to me it's embarrassing, right? It's embarrassing because it did not need to be that way, and
Mm,
we're out there ultimately being role models for students and people watching what's going on, and that's not what you want your life to be like in science. You don't want it to
mhm,
be toxic. You actually want it to be, I should say, a bit of competition, not bad, but you want it to be friendly, right?
mm.
And so that's why I guess I'm embarrassed by it. I don't think it ultimately interfered in any person's, you know, job prospects or things. It didn't. We didn't get it into it where it became personally destructive, but it was unpleasant and unnecessary.
Can you offer any ways to, I have a large STEM professional audience that, is probably dealing with, many of them are probably dealing with such things now. Can you, not specifically to that rival battle, but, kind of in general, how can you de-escalate conflict? How can you, check these prejudices that you may have or biases that you may have as a scientist? We're not known, as I always joke, how do you know a scientist is outgoing? Because, they look at your shoes when they talk to you. But how do how could some of my listeners, diffuse or detoxify, if such a thing is possible? Remove the tannins. Give me some, give me some techniques or tools that might be have been beneficial, but as you say, it wasn't ultimately devastating, but could have been better both for the younger students witnessing all this. But again, I don't want you to speak specifically about that event. Just generally speaking, how can we as scientists detoxify a toxic situation?
Well, the first thing to realize is that whenever you're feeling anger and emotion, you're not being a scientist, you're being human, and that's fine, but it gets in the way of the science in us. Uh, Trying to allow people easy outs when they've screwed up rather than humiliating them in public, either via Twitter, colloquiums, front page of the New York Times, whatever your flavor is. Don't humiliate people. It's a bad thing to
Right.
do, even when they're wrong. Tell them nice and gently, not this isn't good. And see the world through other people's eyes. Be human about it and say the golden rule. Do I, if I were, was this how I want to be treated? Right? And generally speaking, when you're really angry, chill out. Don't send the email. Have a walk around. Send it tomorrow. Chill out and be analytical about it and take the emotion out of things as best you can.
Mm-hmm.
Because those things set us back and they take the joy out of science if you get it wrong. And for those of us in power, like I have a lot of power now that I didn't have when I was younger. You have the power to, one of the things is not to use power when you have it, but the other thing is to intervene. At a colloquium when people are beating up on the speaker and piling on,
Mm.
stop it. Say, okay, I think we've got enough on that. Let's let the speaker move on, and you can intervene when things are not right, and we need to. We have still a lot of bullying within our communities, and it's really hard to exercise power against others in this intellectual sense, but it's basically humiliate them, and that's you want to avoid humiliating people.
Yeah. And talking about accountability and transparency and really ownership. Last week you had a tweet thread, several tweets about trying to understand your own decision making and involvement in an archive article today. And you apologize for not thinking so much about it. And your mistake is that your participation would provide value to that question. Can you explain why what this article was and why it's significant? It's an article about sort of job and research impact in astronomy. How do you predict it? First, what was the conclusion that maybe you regret being a part of, or can you clarify this? As you did on Twitter to some extent, that you took ownership of this decision and wanted to, apologize in some sense. Can you talk a little bit about this situation, Brian?
Yeah, I'm happy to talk a little bit around it.
Yeah.
This was something proposed by John Cormandy, where he wanted to calibrate citations with a group of people from different fields to just sort of, say what is an individual's scientific output relative to their citation output. Now,
Mhm.
I was at the time, I hadn't really thought through what exactly that meant when put onto paper. I was
Right.
interested in just the whole notion of overuse of citations and boiling everyone down to citations in all sorts of ways, and I was worried about that. So, in some sense, I was interested in seeing, are we going to find out that planetary science has a very different citation curve than cosmology and things like that?
Right. Hmm.
And I wasn't really thinking through the social construct of having, 21 elite people, very homogeneous group of 21 people when you look at it,
Hmm.
casting and putting ourselves in that position of power and saying we are God, and so the tone of the paper ended up being something I was pretty deeply uncomfortable with, and I just hadn't really thought through, and I wasn't. I will say John gave me every opportunity to understand what he was doing, and I feel like I've let him down because I did not pay enough attention to understand what was going to come out. Uh, but I am very concerned about um, using only those types of measures that make us hyper competitive. There's gatekeeping that I talk a little bit about in the tweet, where you're only really, you got to get the break to get into the university, to get into the PhD lab, to get the prize postdoc, to
Right.
even be in this bit. And so there's a whole social thing there that I think that paper missed out on. And I know, having talked to John, I think he's pretty upset, and he's caused he didn't. I don't think he wanted to cause that amount of upset. But in the end, I should have thought through what I did and realized what we were doing was probably very much out of touch and out of tone of the community we want to have, which is we want it to be inclusive and we want to support excellence, but we don't want to gatekeep excellence, which I'm afraid a lot of what and how our field and academia in general works, unfortunately, is it tends to only give opportunities to those who have had opportunities ahead of time.
Matthew effect on display. Thank you very much for that. And as I said in my response to that tweet, your candor and ownership, because I think it's very rare, and I think that's a teachable moment, if you will, for young people to see that you can. I don't want to say make mistakes, but that we're human beings, as you said earlier. When you have any kind of emotion, there's a disservice done by assuming that we're just dispassionate observers of factual, rational reality. I think that drives a lot of people away. As Jim Gates said when he was on the podcast, he was like, "I never thought I'd be Einstein, but that's okay. Einstein wasn't always Einstein." And I think we promote that myth of infallibility to our detriment, because I think it does exclude the broadest panorama possible. I want to wind up because I know you only have a few minutes left, but I want to just kind of touch base with, as I said, this notion that you found it very important to have an intellectually diverse set of team members on your team, including theorists and physicists. Gasp, physicists involved, including your former office mate. Your former office mate was Sean Carroll. He wasn't a member of the team, but people like Chris Stubbs and other folks, physics and astronomy hybrids, etc. But theorists, talk about the importance of that, and what role that plays, and having a true, panoramic, synoptic view of a field. Does it require that, or can we put our heads down, just talk to those of us who are like those of us, and make a lot of progress? Because we have theorists and we have data scientists working on it, but it's not clear that all my students, shall I say, I mean, this is probably my fault, but that they really have kind of the broad scope of history and all the different panoramic contributions that are necessary to make a huge caliber discovery. So maybe, comment on kind of the breadth versus depth, if you will, and the importance thereof.
Yeah, it was a big project, and I really appreciated having a bunch of people with specific skills and some people who could see things from the different part. And so I did really want to have that intellectual diversity and fessing up. We had 20 people on the team, but no women. So we didn't get it
Mm-hmm.
all right. And if
Right.
I could go back in time and fix that as a 27-year-old, I sure would, because I think you know, that was part of our, a missing part of our team when I look back at it. So if you're going to solve problems, if they're simple problems, okay, you just, you have a hammer, you smash the nails. This was really hard because we were having to do a whole bunch of things. We were going to having, to schedule people and telescopes around the world. We're having to write software that had not been written before. We were having to process the data really, really fast. We were then having to send it across and then do a very detailed analysis. And we did a full Bayesian analysis in 1998. It's literally one of the first
Yeah.
ones of those ever done, and I wasn't taught that. And
Right.
Adam kind of teaching me via Bill Press on the phone, and we were only able to do that because of that diverse group of people came together.
Mm-hmm.
And so you don't really know you need diversity, but it's always useful. And as I said, I regret not having a more gender diverse team. It's one of my big regrets in all of that.
And lastly, I want to know, what is your daily life like now? I mean, modulating out COVID, obviously, that's hopefully time limited, duration limited thing, and Australia's reaction, notwithstanding, in terms of uniqueness versus the U.S. But what is a vice chancellor, which, as you say, is tantamount to president here in the U.S. or chancellor here? Talk about what is that life like? Is it how do you go from astronomer to vice chancellor? Because it seems like you would have to do a lot of reading, or maybe change gears radically. So talk about that change from astronomical group leader to now academician, as we would say.
Yeah, well, it's a big jump. Ultimately, being a leader of a university in Australia, it's a little different than the U.S. president because you've got the outward bit, but a lot more of the inward bit too. So it's sort of the president and the provost combined.
Hmm.
So I had to learn a lot, how do university budgets work really well? How do you improve the processes in a university and all these business-like things? But ultimately, it comes down to people, right? Being ahead of a university is ultimately about empowering, rather than just your group, all sorts of groups in all sorts of areas and getting them to work constructively together,
Hmm.
and getting things done. So the work I did with people, I think, is the single most important part about being a university leader. But then you have to learn some of the mechanical bits around, how do you run $1 billion organization, and listening and talking to people who do management and talking about it is important. But we also have to remember universities are not companies. And so most of the management theory you're going to learn is all about running a company. And I'm telling you, that's not what a university is. I mean, and a lot of universities have become like companies, but then I don't think they're very good universities. They're machines for producing undergraduate degrees or something. So it's been an interesting journey of learning for me. But in the end, the rules around a group of six actually apply to groups of 5,000.
Hmm.
Um, Treat people with respect, listen to them, understand things from their perspective, and try to get them to play nice in the sand yard, in the sandbox with each other. That's sort of the goal. And then, of course, get out and tell people around the world what you're doing and why it's exciting. And that's sort of my job, in fortunately many hours a week.
Do you miss the telescope time? Do you miss the teaching or academic pursuits of a researcher more than you thought you might, or are you comfortable kind of not being in the day to day grind of professional astronomical life?
So, I mean, I knew I was going to miss it. I knew what I was signing up for.
Hmm.
But I've been out now for almost 6 years, and yeah, I'm really beginning to miss it. So,
Yeah.
I will be an astronomy professor once again, but I'm going to have to come into sort of this, rebuild myself for several months to get my skill set back up, and that will be interesting. And so, indeed, so it's here early in the morning, and my first meeting of the morning is starting in 90 seconds. Then it's back to back for the entire day.
Okay, I'll take that as an opportunity to ask you one question of my final three patented questions, if you'll be so kind. I want to ask you, Brian, if you can summarize kind of what you would put on a so-called monolith. Arthur C. Clarke had these monoliths in 2001. They're kind of time capsules. They're kind of devices meant to ward off disaster. Can you say what piece of information would you most want to put on a time capsule to last 1 billion years?
Uh, the future is more important than you think.
Right. That could also pass for my advice to your former self. The only way of discovering the limits of the possible is to venture beyond them into the impossible. Origin of my podcast name, Brian Schmidt. Thank you for spending time with another Brian, on sharing some of your valuable time with myself and my audience. I can't thank you enough.
Great. Thank you very much. Take care.
Thanks,
Cheers.
Brian.
Any sufficiently advanced technology is indistinguishable from magic.